Hi, everybody. Today we're going to continue on with solving quadratics with a special focus on the quadratic formula and the discriminant. Okay, well, so far on quadratics, where are we? Well, we started off with solving them using square roots. We did x squared minus 9 is 0, for instance, and found that x was plus or minus 3. We got that by taking the square root. And then we looked at perfect square polynomials, and we found out there was one solution. And then we started factoring, and we were able to find factors that gave us our zeros. This is an example where a was equal to 1. That's 1x squared, but it might have been 2 or 5, and we know how to now do pretty much any quadratic because now we know how to complete the square and use the quadratic formula. So let's begin by using completing the square to solve a particular quadratic that doesn't have roots that are easily found. So complete the square. We set it equal to 0, send the constant over to the right. Now we divide everything by 2 to make my coefficient for x equal to 1 right here. Okay, we end up with x squared plus 8x plus 16 is 39 over 2. That factors into x plus 4 squared. We take the square root of each side and solve for x. Now, the square root of 39 over 2, that's a little bit problematic. Let's fix that up and turn that into the square root of 78 over 2. Now, just to take a look at how we did that. Well, we had x was minus 4 plus or minus the square root of 39 over 2. And I say that that square root of 39 over 2 is the same thing as the square root of 78 over 2. And how do we get there? Well, recall that if we have the square root of a quotient, we can take the square root of the numerator and the square root of the denominator separately. But we have to make sure that the denominator contains no radicals. We have to rationalize the denominator. Okay, so when we do this, to square root of 39 over 2, we get this radical 2 down below in the denominator. We need to rationalize that. So I'm going to multiply it by 1. The square root of 2 over the square root of 2 is equal to 1. And that allows me to say square root of 2 times square root of 2 is equal to 2. And now my denominator is a rational number. And you might look at the square root of 78 and say, can I simplify that? Well, it works out when we factor 78, it's 2 times 3 times 13. All of those numbers are prime, so you're not going to be able to reduce that radical 78 any more than it is. Just a quick little reminder about the vocabulary. The sign itself is called the radical sign. And then all the stuff inside, like say the 78, is called the radicand. We'll be using those words in the near future. Okay, back to the quadratic formula. Let's go back to this. We had left off here. We had found the square root of 78 over 2. So simplify this. Negative 4 is minus 8 over 2. This is common to have the same denominator. And minus 8 plus or minus radical 78 all divided by 2 is approximately minus 8.42 and 0.42. Okay, now we'll go back to the quadratic formula. So here it is. I always jot it down at the beginning of a problem just to remind myself of what it is. And we're going to use that now to solve the same problem that we just did completing the square. 2x squared plus 16x minus 7. This time, though, we want to take note that a is 2, b is 16, and c is negative 7. All right, my quadratic formula, like I say, I jot it down, and now I plug in my values right there. Plug them all in, work them out, you get the square root of 312. It works out that 312 is 4 times 78. Take the square root of 4 is 2, and the square root of 78 we're stuck with. We're right here, we simplify, and that should look pretty familiar because it's exactly what we got when we were completing the square. A quick little sketch of this is easy now that we know the zeros. We know that we have a 0 when x is 8 minus 8.42 and positive 0.42. Is my minus 8.42, and there's my positive 0.42. My y-intercept when x is 0, here's my function, when x is 0, 0, 0, negative 7. When x is 0, y is negative 7. There's my y-intercept. The axis of symmetry, that's x is minus b over 2a. So b is 16, minus 16 over 2 times 2 is 4, minus 16 over 4 is negative 4. So my axis of symmetry is x is negative 4, and there it is coming right down, right through my vertex. My vertex, I know that x is minus 4. What's y when x is minus 4? We figure this out right here. Take out x, put in negative 4, and when you do that, it works out that f of negative 4, or y, is equal to negative 39 when x is minus 4. And that's this point right here at minus 39. We have this point, we have this point, we have this point, we have this point. Notice the symmetry. I know that right here from here is 4 units. So if I move over the same direction, 4 units in this direction, I should end up at 8. Negative 8, I should say. And that point right there is x is minus 8 and y is negative 7. And you can plug this right back into the formula up here and check for yourself. Okay, another example from the past was one that had no solution. This was when we were drawing quadratics quickly. And I gave you an example of x minus 4 plus 1. And let me just sketch it right over here. There's 4. X minus 4 was something like this. And then we added 1 and it brought it up by 1. So this was an example of a quadratic that had no solution. Okay, so that's what I say right here. X has no solution. But let's see what happens when we plug this into the quadratic formula. When we work this out, it was x squared minus 8x plus 17. So a is 1, b is negative 8, and c is 17. My quadratic formula, plug in my values, and I get the square root of 64 minus 68. That's going to be a problem. The square root of negative 4 is a showstopper, and we can't go any further. So this idea of what's going on inside the radical, the b squared minus 4ac, plays an important part. Okay. B squared minus 4ac really does tell a story, so much so that we give it its own special name called the discriminant. If it's negative, there's no solution. So we have 3 possibilities, if you remember the law of the trichotomy, that a number is either negative, 0, or positive. So that's all we have to do is check those 3 cases. Let's check to see what happens when it's positive. Well, that means I get the square root of a positive number, and I'll have minus b plus the square root of that number, and minus b minus the square root of that number, and I'm going to end up with 2 solutions. If b squared minus 4ac is equal to 0, I get the square root of 0, which is just 0. In other words, I get minus b over 2a, and that's the axis of symmetry. And that's what happens when that polynomial is a perfect square. And then finally, what we just saw was if b squared minus 4ac is less than 0, the one we just saw was negative 4. We're taking the square root of a negative number, and that just can't happen with real numbers. So this idea of b squared minus 4ac having a lot to say is really true. As a matter of fact, we can look at it and tell how many solutions there are in the quadratic. We give it its own special name. I know it's called the radicand, but because it plays such an important role, it's also better known as the discriminant. And that's it for today, guys. Stay safe. Hope everybody's well.